Okay, I'm here with Shaun Moss of International Mars Research Station. Thanks for joining us, Shaun.
Thanks, Heidi. Thanks for asking me.
Um, so eh, you, how about you tell us a little about the International Mars Research Station and what a typical mission would look like?
Sure. So it's basically a concept. You could consider it as similar to the International Space Station, but on Mars, involving a collaboration of countries. I would aim for about 10 of the major spacefaring countries around the world to collaborate on building a base on Mars. And this would be of great benefit to everyone involved and to the whole planet. Uh, a mission to the International Mars Research Station, the architecture for the IMRS is new. It's been developed to support the idea. A typical mission would look something like this. So we would construct a Mars transfer vehicle on orbit, in Earth orbit. Um, we, there would be an initial pre-deployment phase where all of the major components for the base would be sent to Mars in advance of the crew. So this would include a Mars ascent vehicle, which would include equipment to manufacture ascent propellant from the Martian environment. It would include a surface habitat, a multi-purpose pressurized rover, and one or more capsules with cargo, supplies and equipment, that sort of thing. This would be all sent out in advance. The Mars ascent vehicle would begin manufacturing its ascent propellant from local water and carbon dioxide, and the surface habitat would begin making air and water for the surface mission. So the next available launch opportunity, about 26 months later, the crew would launch from Earth in a Dragon capsule on a Falcon 9 rocket. This capsule would dock with the Mars transfer vehicle and the crew would enter the Mars transfer vehicle. That capsule would remain docked to the Mars transfer vehicle for the trip to Mars, which takes about 6 months. On arrival at Mars, the Mars transfer vehicle would park on Mars orbit and the crew would use that capsule to land on Mars near the surface hab. So we don't expect them to walk to the hab from the landing zone. So the rover, the multi-purpose pressurized rover, is driven to pick them up from the capsule and they would drive that back to the surface hab. So that would sort of begin the surface mission. The surface mission takes about 18 months while the orbits of Mars and Earth line up again. Then the crew would they would drive the rover to the Mars ascent vehicle. That would launch from Mars. The top of the Mars ascent vehicle is another Dragon capsule. This would dock with the Mars transfer vehicle. The crew enter the Mars transfer vehicle, and that capsule is then jettisoned and left behind. That's mainly done to reduce mass, but it also serves purpose in terms of planetary protection. The Mars transfer vehicle flies back to Earth, takes about another 6 months, and parks on Earth orbit. At this point, another Falcon 9 rocket would be launched from Earth with another Dragon Rider capsule, which would dock with the Mars transfer vehicle, and the crew would use this to land on Earth. After this point, the Mars transfer vehicle is in Earth orbit. It would then be refurbished and refueled so it could be used for the next mission.
Okay. What would a typical crew for the International Mars Research Station be like?
The size of the crew is 6. This is done for a variety of reasons. Most of the research around sort of optimal crew size for the first or the early human missions to Mars produce a number of about 6. That's what NASA's design reference architecture is designed for. Also, a Dragon capsule can carry 7, so it'll fit 6. The habitat modules that I'm including in the mission have life support for 6, so it's just the right number. This would be 2 teams of 3 people each, an engineering team and a science team. Each person on the team would basically do 2 similar roles. So we'd have a flight and mechanical engineer, a mechatronics and communications engineer, and a chemical and electrical engineer. We would have a planetary scientist and astronomer, a astrobiologist and horticulturist, and a medical and safety officer. So this is what I think would be a well-rounded team of 6 to go to Mars.
Okay. NASA's 90-day report called for a plan that would have cost $450 billion. How would plans like the International Mars Research Station keep costs down?
There are a few ways actually. Um, One of the main ways is to reuse the hardware as much as possible. So if you think about the Mars Analog Research Stations, if you think about the ISS, we construct a base and we run multiple missions to that base. Compare that with something like Apollo, where each mission is to a different location, so you have to use and send new hardware every mission. Right? This is a much more expensive way to do it, and it's too expensive an approach for Mars. So we focus on a single location. By pre-deploying the habitat, we only have to land that once, and landing a large object like a habitat, which probably weigh in the range of 20 to 30 tons, will be very expensive. So we by landing the habitat, um, uh, a single habitat, and reusing it for multiple missions, that saves a lot of money there. Landing crew and cargo in capsules will be a lot cheaper. We can, by focusing on a single location, we can reuse the HAB, we can reuse the rovers and the all-terrain vehicles, we can reuse the in-situ resource utilization hardware and anything else that we send to the base. What else can be reused is the rockets. So you probably know that SpaceX is now making their Falcon rockets reusable. This is estimated to reduce the cost of launching anything into space by a factor of about 100. So we use reusable rockets as much as possible. Another important element is in situ resource utilization. So we try to make as much as we can from the resources available on Mars. So in the architecture for the IMRS, we're making water, air, and ascent propellant, all from local Martian resources. So we don't actually take any of the ascent propellant to Mars. We use Martian water, Martian carbon dioxide to manufacture oxygen and methane. By doing that, it makes the Mars ascent vehicle a lot lighter. It can be landed empty, and that is also a big cost saving. There's obviously some development costs, some technological challenges involved in obtaining water from Mars, obtaining water from the ground, but I believe that it's achievable. It will be achievable within the next 20 years, and it's something that we can certainly do. And the benefits for the architecture overall is overall lower cost and better mission. If you look at it this way, people living on Mars are going to have to learn how to access water on Mars sooner or later anyway. So we might as well develop that capability now. Conceptually, it's not that difficult. Another way that we're reducing costs is by involving lots of countries. Right? I'm aiming for 10 in this profile. So if you consider one country trying to do a Mars mission, it will be too much of a financial cost for that one country, but if you spread it across 10 countries, it's a lot cheaper. And also, by involving more countries, you can make use of more resources that are already available. So facilities, people, other resources that are already available, they don't all need to be developed new, because by involving more countries, you've got more stuff that can already be used.
Okay, can you tell me more about the benefits of making manned missions to Mars an international effort?
I think philosophically they should be. I think that it's widely believed or acknowledged that Mars is a future home for all of humanity. It's not the domain of any one single country. I think inevitably, as we expand into space, the concept of nations will disappear anyway, and eventually Mars will be home to all of humanity. Or people from all over the Earth. So I think we need to start with that idea in mind, so that the seeds we plant now of the future Martian civilization are good, they're philosophically good. That we're doing this not for to support some outdated nationalistic ideology, but for the benefit of all humanity and for all life. Okay, I think that is a more noble attitude to have. Also, as I said before, by involving more countries, you save money per country. Okay, if you spread it across 10 countries, it's only 10% of the cost that each country has to wear. And also, you have access to more people, more engineers, more facilities, more resources. And what's I think another benefit, great benefit, is that more people will benefit. If you see someone from your own country going to Mars and back, that's more inspiration for you. If you see someone from another person's country doing it, then it's more of a, like, why aren't we doing that as well? Or perhaps not as much of an inspiration, but if the more countries that get involved, the more people that will benefit, the more children that will be inspired to take on an engineering science or a science education, the more benefit that people will get from their country or their people having that first-hand experience of an interplanetary mission. And this is a really noble and historical endeavour. There are few things that will ever happen in human history as important as going to another planet, and especially colonising another planet. So the more people that can benefit, the better.
Awesome. What challenges do you think we'll have to face before missions like the International Mars Research Station can become reality?
Um, I think that the main challenge is a certain leadership and vision, and it can't come from just one place. It's got to be understood that that human expansion into space is a benefit for everyone. So we need leaders to start emerging who can communicate that, and political leaders who can take on that voice and say, okay, this is something that we need to do. It needs to be backed up with confidence, with technology, innovation, financial commitment, and there needs to obviously be, it needs to be sort of well established that this is a benefit, so that it can be understood by many people and by many countries, and that they will see the benefit in cooperating on this and making this happen. So I think one of the obstacles that we face at the moment in the world is greed. Greed of corporations, greed of people behind corporations are destroying life on this planet. This is a big obstacle. We need to get rid of that mindset. We need to replace that with a visionary mindset. Human expansion into space will give us access to all the resources we could ever need. So all of this petty squabbling on Earth that we do for over resources and people being greedy, all that can be done away with human expansion into space. This is one of the primary benefits of doing it. But that understanding needs to be commonplace. We need people to see that, yeah, that this is the way that we can eliminate most of the problems and the greed and the conflict that we have on Earth. Another challenge that I think that very significant challenge that we face is the environment. Okay, our environment is currently out of balance. We're going through a mass extinction, the biggest mass extinction that's happened in 66 million years. Ice caps are melting and so on. I think that a lot of government resources and time is going to be occupied with addressing the problems that we will face related to the environment over the next couple of decades. And that's an obstacle, right? Because it's going to draw resources away from space exploration and development. So these are, I think, the major challenges, but I also think that going to space is largely a solution, a partial solution perhaps, but it will have a great benefit because of the access to resources, but also because of the global unity that can come from, for example, going to Mars on an international mission, also from the science and engineering and the technology that will blossom as we go into space, because these same technologies can be used on Earth to solve a lot of our environmental and resource problems. So, yeah, that's what I think are the main challenges in the way right now. A change of mindset is necessary. A change of mindset from nationalistic thinking, from greed thinking, from focusing on getting more money and thinking about planetary systems, thinking about what benefit can we create for all humanity, what kind of future do we want to create, and how are we going to get through the challenges that are ahead of us.
Okay. Yeah, uh, is there anything I didn't think of that you wanted to add, Shaun?
Uh, I'm not sure right now. I think that covered sort of most of what we were planning to talk about.
Okay.
My book is just about to come out. It's called The International Mars Research Station, an exciting new plan to create a permanent human presence on Mars, and it'll be up on Kindle probably within a week. I'm just in the formatting stages now, so I'm going to be posting the links around to everyone in the Mars community pretty soon. So watch out for that, and it'll be a free download for about a week. And so hopefully that will serve to communicate the plan and these ideas a little bit more.
Sure, and I'll post a link to your book on the YouTube video when it's up and going, okay?
Awesome. Thank you so much.
Thank you. Yeah.